so we are working on problem number 6. All right, so two different situations. All right, one of them is a plane going upward. One of them is a plane headed downward. All right, and the question, let's be real clear about what the question is. The question is, read it to me, Shams.
For number 6, part A, the question is, during each of these motions, the lift force L acts perpendicular to this displacement S, which has the same magnitude of 1.7 times...
That's not the question. What is the question?
Okay, yeah. Is more net work done during the dive or the climb?
All right, thank you. Is more net work done during the dive or the climb? All right, let's take a look at the forces that are acting, okay? So we have weight acting downward. We're just going to make that come from the center of the plane. In each case, all right, this is the same, right? In each case, the plane is the same plane that has the same weight, all right? It gives us a thrust, and we'll make thrust green because green goes. All right, so we have the thrust. In each case, it is the same. That is to say, the magnitude of it is the same. It's not going to come out to be perfectly the same, but for our purposes, we will consider it to be the same. We have a displacement vector, which we will make red in honor of Shems's use of red for displacement. All right. Now, we also have a lift force, which is going which way? Perpendicular to the thrust. All right. I'm going to make that blue as well because I'm running out of colors. All right. So perpendicular to the thrust and most notably perpendicular to what? Thank you. Perpendicular to the displacement. All right, so let's take a look. The net work, we will do this one this way. Net work is the sum, that's an F. F stands for force. Net work is equal to the work done by all the sum of the work done by all the individual forces. That's why we're going to approach this. Instead of thinking of it in terms of net force. All right. So in each case, so we're going to say in the climb, all right, we have some displacement S. So S for the climb, and for the dive, we have displacement, we'll use S for the dive. We know that they are equal, right? We know that the thrust is equal, right? So here's the thrust. Thrust for the climb, thrust for the dive is equal. The displacement is equal, the force is equal. The angle between them, equal. Thrust and displacement are in the same direction. Excuse me. So this case right here, work done by thrust in the climb is equal to work done by thrust in the dive. Why? Because the force, the displacement, and the angle are all the same. So there's no difference in each case, in either case, for the work done by the thrust. Everybody cool with that? All right. The lift force is even easier, right? The lift force in the climb and the lift force in the dive, we know they're the same, but you know what else? We don't care about it. Why? Right. Lift is perpendicular to displacement. Therefore, the work done by lift is equal to 0. Okay? So, the work done by the thrust, the same in each case. The work done by lift, the same in each case. So the only difference we're going to see here is based on the work done by what? Gravity, the gravitational force, all right, or the weight of the plane. All right? In each case, the actual magnitude is the same, but as Shems pointed out, it's this angle with respect to the displacement that is going to be the deciding factor. Here, you said this was 75 degrees, is that correct? In the dive? All right, and 115 degrees in the climb. All right, well, let's just take a look. Let's come all the way down here and take a look real quick. I'm going to make this easy. What's this, guys? Cosine curve, all right? So here's 90 degrees. Here's 180 degrees. 75 has a positive cosine. 115 has a negative cosine. So even without doing the math, any math at all, we could see that since the total work in the climb is going to be equal to the work done by the thrust, plus the work done by the lift, plus the work done by its weight, and the work done during the dive, work done by thrust, plus work done by lift, plus work done by the gravitational force vector, okay? We know if we compare these that that's the same as that, that's the same as that. In the case of the climb, this is negative. In the case of the dive, this is positive. So in which case is the amount of work done going to be greater? It has to be in the dive. Okay? Now does it say in which case is the magnitude of the work, or does it say in which case is the work greater?
It's more not work done.
Okay, so in this case, in other words, we're doing more work because, remember, it's not a vector, so we don't care about direction and say it's more work in this direction, more work in that direction. In either case, it's just greater because it's positive. In which case is the plane going to speed up? Do you imagine? This one right here, when it's diving, okay? Right, so if we got positive work when it's diving, it's going to speed up, right? We've got positive work. We're increasing its kinetic energy. All right, so now the second part of the question we will address in a second.